This video still covers 9.2 surface area of pyramids. Now we're moving on to example 3, which is regular triangular pyramids. And so what your textbook means by regular, again, it means all the sides are the same length. So if we're talking about a triangle, this would be an equilateral triangle. Of course, they don't say that. They like to confuse you. So they say the word regular, but they mean an equilateral triangle. So you need to know that information to be able to find the area of the base and the area of the lateral faces of your triangle. So to start, let's draw a picture of a triangular pyramid. So start with a triangle base. Try to make it an equilateral triangle. Not that it really matters, but that's what it's supposed to be. And then one vertex at the top and straight edges down. So let's label this 10 meters. So 10 meters is from here to here. And again, if that were an equilateral triangle, which it's supposed to be, it would mean that this and this side would also be 10. But in your pictures, they only like to label one of the sides. They try to make it a little bit confusing on you. And then I just want to draw it like your textbook does. Let's go like this. They might tell you that you've got a dotted line here with a little right angle. And this particular example, they say this is 8.7 meters. And so that represents the height of just the base. Now you might have some other lengths. You might have another dotted line that goes down this way with a right angle. And they might say this one is 14 meters. So that's the height of just one of the lateral faces. That's what that represents. And then you know that the base of that lateral face, again, since this is 10 going this way, this would also have to be 10 to the left and 10 to the right. And so it's a little bit confusing because it almost looks like you're missing numbers at first, but you just have to apply what you know about equilateral triangles. So just like the problems from yesterday, I would suggest finding the area of your base first. So area of base. And now yesterday all of the shapes were squares. This time for your base, this time you have triangles because these are triangular pyramids. So you're actually going to use base times height divided by 2 to find the area of the base. And so I'm going to highlight it in blue right here. That way you know what I'm looking at. There's only one of these triangles. So you've got 10 by 8.7, and then you'll need to divide by 2 at the end. So we've got 10 times 8.7 divided by 2. 10 times 8.7 would be 87. And then 87 divided by 2 is 43.5. So this is just the area of your base. Now, I'm going to change my color. I've got area of LF. Remember, your lateral faces are the triangles on the sides. So let me highlight one of them. Okay, you have a base times height divided by 2 because it's a triangle again. Remember, if this is a regular triangle or an equilateral triangle, this base down here is also 10 meters. So you've got 10. The height of your lateral faces, that's what the 14 represents, and then you'll divide by 2. So this is 140 divided by 2. So one lateral face is 70, just one. Now, if this is a triangular pyramid, I'm going to draw you a net. There's your base. You would only have 3 lateral faces, LF, LF, LF. Yesterday you had 4 because it was a square base, but today with triangular pyramids, you have 3 lateral faces. So we're going to multiply times 3, and that would be 210. So then your last step, so this 210 represents all three lateral faces. Your last step is to add your lateral faces, so the 210, with the area of the base, remember, which was 43.5. And when you do that, you get 253.5. That would be your final answer. Make sure you're paying close attention to the directions, because if they ask you to round, of course they need you to round. But your two problems you have today look just like that. Find the area of the base first using this formula. Then find the area of the lateral face second using the same formula. Because with triangular pyramids, all of your faces are triangles this time.